Machines and fixtures frequently have to be re-equipped for different operations. Each change necessitates a change to the control operating sequence. The following allow variable programs to be used: camshaft, cam belt, punched card, punched tape. Camshaft. The simplest program carrier for variable programs is the cam plate on the camshaft with drive via geared motor or stepping motor. Program change is best accomplished by replacing the camshaft. If several signals are to be produced during one revolution of a signal transmitter, several cams are required. In this case, however, the signals can no longer be scanned reliably. The cam belt represents an extension of the cam shaft. Cam belt. With the cam belt, information for providing the signals is given by cam. The cams are attached to correspond to the program sequence. The program duration is determined by belt length and rotational speed. Small modifications to the program are made by reattaching the cams on the machine, whereas larger program modifications are accomplished by replacing the complete belt. Punched card. The operating principle of the punched card is based on the air flowing through the perforations in the card, triggering control operations. The information is condensed into a small space. Programming of the punched card is performed step by step, the necessary outputs being entered one beneath the other. If in the diagram a change takes place from O to L, a hole must be made in the card. If signal L is to be retained, the card is also punched. If the signal changes from L to O, or if the O signal is to be retained, no hole may be punched. First step. In column A, a change takes place from O to L. The card is punched. In column B, we have an O signal, and the card is not punched. Second step. In column A, the L signal is maintained, and the card is punched. In column B, a change takes place from O to L. The card is punched. Third step. In columns A and B, the L signal is maintained, and the card is punched in each column. fourth step. In column A, the L signal is maintained and the card is punched. In column B, a change takes place from L to O, and the card is therefore not punched. This is performed for each step and output. Whole sequence A. Whole sequence B. A rotor distributes the air for the individual steps. The movement from step to step depends on feedback signals. A supply channel is required for each step. The punched card is placed in the card holder. The air flows upwards through this hole in the card and flows to the assigned output via a distribution plate. A distribution plate is provided for each output. The plate has a channel leading to the output for each step. In distribution plate C, for example, an output signal is issued in the second, fourth, and 11th steps. Since the signals are issued in a low pressure range, they must be amplified. The program is limited by the size of the card. This card, for example, contains a test program. The following are to be tested: function and absence of leakage for a valve at various working and control pressures, as well as different types of actuation. The perforations in the card are read step by step. If another part is tested, the fixture and program carrier must be replaced. Punched tape. Manufacturing sequences can involve a program which is too large to be stored on one punched card. Punched tape can accommodate a larger program. A punched tape can simultaneously control up to 8 outputs with a large number of steps, which is limited only by the length of tape. Here too, the holes are sensed by means of compressed air, but in this case on the back pressure principle. This means we have an O signal at the signal output of a back pressure nozzle as long as a hole exists in the program carrier being read. In order to avoid the need to reverse the many instructions when programming, namely O in L and L in O, it is simpler to provide signal reversal by means of control techniques. Thus, we have to negate the signal. By using a suitable element, the amplification can be performed at the same time. A hole in the tape provides an O signal at the back pressure nozzle and an L signal at the amplifier output. No hole in the tape provides L, and thus O at the amplifier output. Eight channels and the feed track are read. If we consider the track right at the front, a hole provides an O signal. No hole provides an L signal at the output of the back pressure nozzle. A press pad pushes the tape onto the nozzles of the reed head. Signal expansion by logic operations. By means of logical combinations, the output signals can be multiplied. Thus, for example, if signals E1 and E2 do not exist, then we have A1. If only E1 exists and not E2, we obtain A2. If only E2 exists and not E1, we obtain A3. If the signals E1 and E2 exist, we obtain signal A4. Here, from 2 input signals, we have obtained 4 output signals. By linking signals, up to 128 outputs can be obtained. Let us summarize. Where the extent of the program is small, we use cam disks. The extension of this design is the cam belt. The punched card is suitable for frequent program change and rapid modification of the operation on the program carrier. The punched tape allows the use of extensive programs. These freely programmable controls are termed variable programs.